All right, you're going to want to stick around for this because today we're looking at a brand new physics simulation that tackles one of the biggest, most fundamental questions you can possibly ask. We're talking about building an entire universe from absolutely nothing. I mean, that's the ultimate puzzle, isn't it? You look around, our universe is just jam-packed with, well, stuff, stars, galaxies, us. But if you could rewind the clock all the way to the beginning, before the beginning, where did it all come from? How do you get a cosmos brimming with matter and energy out of a state of perfect, total emptiness? Well, this absolutely fascinating paper decides to take that question head-on. The author calls it a numerical existence experiment. And the goal here isn't to perfectly replicate our universe with all its complicated physics. Nope. The idea is way simpler, and maybe even more profound. Let's just start with an empty digital box, give it a few basic rules, hit play, and see if a universe of something can spontaneously build itself. So, if you're gonna cook up a cosmos from scratch, you need a recipe, right? This isn't just about throwing random stuff in a box. The simulation is built on a very specific and surprisingly simple set of rules.
Okay, the absolute core rule here is something called spontaneous paired creation, and it's based on this really elegant idea. Picture a perfectly flat patch of ground. That's your nothing. Now the rule is you can dig a hole, let's call that your negative energy, but only if you use that exact same dirt to build a mound right next to it, your positive energy. See? You've created something from nothing, but the total amount of ground is still perfectly zero. The books are balanced. That's the key principle here. These tiny curvature defects, little particles of positive and negative mass energy, can just pop into existence, but always in pairs, keeping the universe's net energy at a nice, tidy zero.
So how do you get from that rule to a whole universe? Well, it's a step-by-step process. First, you start with that totally empty 3D box. Then you just let these positive and negative pairs start appearing all over the place. Pretty soon, they start interacting, pulling and pushing on each other with a kind of gravity. And now, here's the real game changer. If one type of particle, the kind that likes to clump together, gets a little too crowded in one spot, it triggers a collapse. That super dense clump gets taken out of the simulation and is instantly replaced by a brand new, stable, spinning object. Okay, so the rules are in place. The cosmic engine is ready to go. Let's press play and actually watch what happens inside this little digital box as it tries to evolve from pure nothingness. And this is what it looks like, right at the very beginning. The box starts as a perfect void, utterly empty. And then, slowly, you see these pairs of defects begin to appear, kind of like the first few drops of rain on a perfectly still pond. It's this quiet, gentle awakening, as the first seeds of existence are sown into the nothing. Let a little more time pass, and the creation process just keeps going until the whole box is full. At this point, though, it's just a chaotic, uniform soup. It's a random mix of these positive and negative particles buzzing all over the place. There's no structure, no order, just a seething gas of pure cosmic potential. But then, gravity starts to do its thing. Those attractive defects begin to pull each other into little clumps. And you know what happens next? As soon as those clumps hit that critical density, bam, the collapse rule kicks in. You can see it right here. These new complex objects, the pink and blue spheres, are literally emerging out of that chaotic background. This is the moment. This is when organized, stable structure is born from pure randomness. Now let the simulation run for a good long while, and this is what you end up with. The entire space is just dominated by these new, stable objects. And they're not just sitting there. They're constantly moving, interacting, swirling around each other like a turbulent fluid. Think about that. The system, all by itself, with just a few simple rules, has self-organized from an empty void into this complex, dynamic, structured state. So, okay, it worked. A universe full of something popped out of nothing. But what is that something? What are these compact, spinning things that have taken over the whole simulation? You know, one of the coolest things that just happened naturally was how the two kinds of defects automatically sorted themselves out. You had the Class A defects, let's call them the builders. They're attracted to each other, so they're the ones that clumped up and got locked away inside those new stable objects. But then you have the Class B defects, the spacers. They actually repel each other, so they stayed spread out, filling all the empty space between the structures. It's like the simulation spontaneously figured out how to separate matter from a kind of background dark sector-like energy.
And the thing is, this wasn't a fluke. The simulation shows that these simple rules pretty much always lead to this very specific outcome. You get a structured fluid made of these newly formed objects, and they all share the same properties. They're all neutral, they're all spinning, and they all have a minimum mass set by that collapse rule.
So this leads to a really interesting question. What could these things possibly be an analog for in our own universe? Well, the paper argues we should think of them as neutrino-like proxies. And when you look at the evidence, it's a pretty compelling case. I mean, think about it. The objects that emerged are neutral. They have no charge. They are intrinsically rotating. They have spin. They form at a fundamental minimum mass. And they end up being the most common space-filling thing in their little universe. So, in our real universe, what's the lightest, most common, neutral, spinning particle that we know of? Yep, the neutrino. It's a surprisingly perfect match. And this is where things go from being just a really cool computer simulation to something that could seriously mess with how we think about the very foundation of reality. I just want you to take a second and let this quote from the paper's abstract really sink in. The Planck scale and quantum mechanics may themselves be emergent macroscopic phenomena. So what on earth could that possibly mean? To get what he's saying, we gotta talk about the Planck length. For more than 100 years, physicists have basically seen this as the absolute bottom floor of reality. It's the smallest possible unit of distance. It's the fundamental pixel of space-time itself. And below that scale, all our physics just stops working. Okay, but here is the absolute kicker. If you take the mass of those neutrino-like objects that emerged in the simulation, and you match it up with the real-world mass of an actual neutrino, you can then work backwards and calculate how big those original fundamental curvature defects would have to be. And the number you get is this one, less than or equal to 10 to the minus 61 meters. I really need you to try and wrap your head around how insane that number is. The Planck length, which we thought was the absolute smallest thing possible, is about 10 to the minus 35 meters. This new number is 26 orders of magnitude smaller. This suggests that what we thought was the rock-bottom foundation of reality, the Planck scale, might actually be a gigantic macroscopic structure, built on a grid that is so unbelievably fine we never even dreamed it could be there. And that just leaves us with this truly staggering thought. This simulation doesn't just suggest how a universe can pop out of nothing. It hints that the very fabric of space-time, maybe even the weird and wonderful rules of quantum mechanics, might not be fundamental at all. They could just be emergent properties, high-level effects of a much, much simpler game being played at a scale so profoundly deep we can barely even write the number down. And if that's true, what other bedrock principles of our reality are just intricate illusions waiting for us to see past them?